from the author. Basically, you have 4 chapters. First chapter, function of several variables. So extension of your engineering mathematics 1, as I said, okay, you calculus, you learn dy dx, mean the differentiation integration. Here, okay, you have function of several variables. Okay, for example, you have z depend on the x and y, so you have more than one variable. So against this one, extension of function of one variable. So we will learn about what's a domain, range, 3D graph, limit, continuity, and so if function of one variable, you can find differentiation. Because here you have function of two variable. Okay, for example, I just something. Let's say z equal to ln maybe x y. So you have z depend on x and y. So this is function of two variable. So you apply now you have two independent variable x and y. So in this case you can find partial derivative. So it's simple, del z. You can differentiate respect to x, or you can differentiate respect to y. This is so-called the partial derivative chain rule without implicit differentiation, and this is an application of the function of several variables. Later on, we have a multiple integration. If we have single function of one variable, for example, y equal to 2x, then you find dy dx equal to 2. But this one is the function of two variables, then you find partial derivative, and then for calculus, you learn how to integrate, let's say integrate x squared dx. Now you have multiple integration. You may integrate, let's say, xy dx dy, and then here you got the limit for the x, limit for the y, or triple. Then you got the dz. Here I just put the so this is a multiple integration. And then the third chapter, vector value function. Okay, normally you learn your vector, let's say 2i plus 3j plus 5k. This is vector with constant value. Now your vector, let's say you have function, your vector is no longer constant value. Maybe like cos t in the component I, sin, this one, let's say sin t, and then this is dk. So this is the vector no longer constant value, but it's a function of, it's a function. And then we look at all the operation deal to the vector value function. The last chapter is the most difficult chapter. It's actually the not the vector field. Suppose this is the main content in this chapter. This is what we call vector calculus. When you combine vector and calculus, so become the vector calculus. So this is the most challenging topic and the most difficult topics here. Here, in calculus, you learn how to integrate one single function with respect to x. In this in this subject, you may have double integral, triple integral, and in vector calculus, you may have the line integral or space integral. So, you will go to learn detail when we arrive to that topics. So, any questions, Any question that you want to ask?
No, doctor.
Thank you. And
Doctor.
Yes.
Doctor, someone want to get in.
You are already enrolled. Already admit.
Alright.
The assessment, you will have quiz 5%, assignment 5%, project 20%, test 1 and test 2 20%, final 50%. So quiz okay, depends on how many quizzes okay, there. Assignment, one assignment, individual assignment. Project, we give the group project. Okay, and this is references. So any question that you want to ask okay, about here? So lesson plan you can download from the author. Okay, project, okay, let's discuss the project first because this is group. Okay, assignment I will give it okay, later on. I haven't decided. Okay, the project you have 20%. So project will evaluate okay, on course learning outcome 1, 2, 3. 1, 2, 3. So look at what's the course learning outcome. Okay, the first one is normally deal with the cognitive, mean the brain. Apply the knowledge okay, of advanced calculus to solve engineering mathematical problem. So this is deal with the okay, knowledge how you solve okay, the okay, this is with the multivariable calculus. CO2 practice the engineering mathematical. It's not well written. This one you apply the knowledge. This one practice the engineering mathematical and perform a presentation or report for guided PBL assignment or projects. CO2. CO3 independently proceed lifelong learning in guided PBL assignment or project. So for okay, what is the skill that you want? CO1 mean the knowledge. So it's a cognitive, using the brain. The second one is a practical skill or modern tool usage. So here maybe we can use a mathematical software. Okay, lifelong learning means you have to you will learn it the whole life or in the project title given is actually all the application. You got 14K title here is actually pick up from 1.4, 1.5 and 2.5. So the meaning of lifelong learning, okay, we will teach you okay, 1.1, 1.2, 1.3, 1.3. And this is application. So okay, each group with 5 person, okay, each group will pick up one topic that says slope of surface. Okay, so mean the topic under the project, okay, we won't teach you. We'll teach you the basics, okay, how to introduce what's function of several variable, how to do okay, all these things, all the okay, the mathematics. Okay. So 1.4, 1.5 and 2.5, this is application. Okay, put it into the project. So you go to pick each group pick up one topic, you learn by yourself. Okay. So your report you must have a okay. Of course, the title page mean the which topic, your name, your member name, okay, everything, and then the introduction. For example, you pick up slope of surface. Then you have to introduce what is the slope of surface, what is that, okay, and then how you solve, okay, how you solve it, okay. You should have okay, the slope of surface exactly represent using what? So what is the methodology? The result, okay, I want the manual. Okay, manual means you do it using hand. Software, you're using the mathematical software. Then okay, where you pick up the example from, you have to put up the reference where you pick up from which book or which website that you pick up that problem. So okay, 20% we evaluate it through. CO1 is a cognitive, mean the brain. So we evaluate in terms of your manual answer and the report organization. So mean all these things: introduction, methodology, result, and reference. How you organize or introduce that topics. So 5%. How you solve it, whether you solve it correctly, manually, 5%. Solve it using software, another 5%. So because your O3 is a lifelong learning, that's why we want you to learn by yourself, and using the software to solve it. So the CLO2, is a practical skill or modern tool. Modern tool is either with software or we want you to record your project that you've done in a video and upload to the YouTube. Because the topic in the project won't be taught. So I want you to record it properly, like you teach how you introduce the topic, how you solve, record properly, put it to YouTube, and your all the students have to view the video, and later on I will create the Google form for you all to evaluate it, and also evaluate in terms of let's look at the YouTube there, how many views and comment from there. So 5% for your explanation through the video. So 5% is whether you answer correct, another 5% your report, written report, another 5% through your explanation through the video. So when your friend watch the video, they can understand what you explain. The third one is a software solution. You can use either MATLAB or Maple. So any questions regarding the project? Assignment later on. Maybe by next week I will give you the assignment title. Here I will upload this to the Telegram. I upload the project in the Telegram first.
Later.
And then please a group consists of 5 persons. So please write down your member. So first come first serve. Write down your group name, members, and which topic that you choose. Topic put up to the Telegram so that I can create the group in the author. And then any more questions?
No, Doctor.
If no, I move to I move to the before I start the lesson, I do the revision on function of one variable, so that later on when you want to find domain and range for function of two variables, it will be easy. So later on, function of several variables, domain and range. And then the function of two variables, so you can plot the 3D graph. This is plotting the 3D graph using level curve and contour line. And then partial derivative, higher derivative. So what we look at. So recall back function of one variable. For example, in general we'll write y equal to fx. Y equal to fx. Y equal to fx. Example, the area is actually equal to pi r squared. Pi is a constant, so mean area of a circle, a equal to pi r squared. So this is an example of function of one variable. So the area depends on the radius. So r is what we call as a domain. Actually, r is the input, a is the output, and then later on, or value of r that can be formed is what we call the domain, and the image is what we call the range. For example, you have the linear function. Okay, this y equal to x. This is a graph of y equal to x. Okay, the blue color is y equal to 2x. So y equal to x, the slope is 1. This slope is 2. That's why it is higher. The slope is higher. That's why you see. So for example, when x is 1, y equal to x, y equal to 1. So here when x 1, y is 2. That's why the slope is higher. Because this y equal to 2x. Okay, when we learn function, normally we'll deal with domain and range. So we call back, domain is actually the value of x. Value of x that you can observe it from the graph. For example, the linear functions here, the linear function, okay, you see in the graph, y equal to x or y equal to 2x, or you have y equal to kx, y equal to kx. In the graph, okay, it takes up all the value of x. All the value of x is not only the 1, 2, 3, it's actually all the real number of x from negative side up to positive side. So that's why D is a domain. Domain we said for function of one variable, domain is a value of x, range is a value of y. So in this case, you see x take up from negative infinity up to positive infinity. Okay, range is actually the value of y. So the y also actually take up from negative infinity up to positive infinity. So this is a domain and range for function of one variable. Okay, before I proceed, okay, who has problem with domain and range? This is function of one variable. Not just go into the your content is function of two variables. Function of several variables, at least two variables there. Okay, if no, then I will just proceed. Okay, the same thing. This is also linear function. So for this case, x plus 2y equal to 6. So what is the domain here? Or for function, you may change it and say y 2y equal to 6 minus x, or y equal to 6 minus x divided 2, or y equal to 3 minus x over 2. Only the slope, okay, here 3, the y-intercept 3. The slope is negative half. Slope, okay, keturunan negative half. This direction is negative slope, okay. This one is positive slope, positive. So okay, for this case, what is a domain and range? For this example, okay, if a function y equal to 3 minus x over 2, what is the domain and range? What is the domain?
Y.
Domain? Domain is value of x. What's the domain?
X equal to.
Faham tak maksud domain apa? Maksud daripada graf ni, ada ke domain yang 0 hingga 6 saja? Domain ialah x. We put it like here. Domain. Okay, domain is actually x. Your x value is it only 0 to 6? And is your graph only like this or not? Actually the graph, this one I just sketched, okay, x from 0 to 6. But in reality, the graph can be extended, right?
Negative infinity to infinity.
Yes, so domain for your x is actually from negative infinity up to positive infinity, where the x is a real number. Real number means it's not only 0, 1, 2, 3. This is integer number. Real number maybe 1.1 or 1.0. Mean got floating point there. So that's a real number. How about the range? Range is a value of y. So y from where to where? Don't look at the graph 0 to 3 only. Y, is it take up positive value, negative value? So what's the y? Okay, y value?
Negative infinity.
Up to,
Positive.
yes,
Positive.
because
And but
this one still revision. If you cannot understand domain and range of function of one variable, so when I move to the actual content, function of several variables, then you will also start with the same problem, you will blur. For function of two variables, your domain is xy value, range is a z value, you will even confuse. So make sure you understand, okay, back function of one variable. So if this is a quadratic function, y equal to x squared, okay, what parabola, so the minimum point at x0, y0, okay, if the quadratic graph, y equal to x squared, I plus 2. So using technique of translation of the graph, okay, the y, initially this is plus 0, that's why the minimum maximum point, the minimum point at y equal to 0. Now y is add up with 2. So the graph will be shifted up 2 units. Shifted up 2 units here. So in this case, okay, I would like to ask you, what is the domain for the y, okay, the function of y equal to x squared? This one. What's the domain? Okay, domain, look at the x value. X. Do you have negative value or not? Positive value or not? Can it
Yes.
Yes, right?
Yes.
I mean, you look at the graph, but don't, okay, don't write for me the domain from negative 4 to 4. For plotting purpose, I cannot plot from negative infinity up to positive infinity, because this is plot using, okay, mathematical software, using Mapper, or I may plot it using MATLAB. Okay, when I plot, I cannot plot, I cannot plot from negative infinity up to positive infinity. That's why I have to put some finite value. But in actual, the graph here is actually can be extended up, okay, from negative infinity up to positive infinity. So, okay, for both graph, actually the domain are same. X is a real number. Okay, the range, okay, for y equal to x squared, okay, you look at the range is y value. For y equal to x squared, do we have negative value of y or not? Do you have the negative value of y?
No.
No, right. Minimum is y equal to 0, right?
Yes.
So that's why the range for the graph of y equal to x squared, the range is actually y greater than equal to 0, where y is a real number. Okay, but for y equal to x squared, domain same, because pick up negative value of x, positive value of x, but the range, you see here, the graph started y, okay, minimum y is 2. That's why the range will be y greater than equal to 2. Then for both k functions here, domain are same, only the range different because for y equal to x squared, minimum value of y is y equal to 0. For y equal to x squared plus 2, minimum value of y is equal to 2. So and it goes up. That's why it's y greater and equal to 2. Okay, is it clear?
Yes, no.
So mean domain is x value, range is a y value, but this is a function of one variable. This one are almost the same. Let's skip to the next one. Okay, if we have the function y equal to 1 over x. Oh, the answer there already. Okay, this is the function y equal to 1 over x. We said domain are the value of x, right? So y equal to 1 over x. This is a graph, y equal to 1 over x. Okay, from the graph you can see that x can never x cannot take 0. Because when x equal to 0, mean your x cannot equal to 0. Okay, why? Because when x is 0, y will be 1 over 0, which is infinity. Okay, function only take up real value. So that's why x cannot be equal to 0. Since x never equal to 0, and the y value that you obtain after we plot, you see y never it touch y equal to 0 too. That's why the range is also y cannot be equal to 0. Because in that case there is no value x. You put x, let's say 0.1. Okay, 0.1, or you can try to put, let's say 1 equal to 1.00001 something. You should get a very big value. Okay, when the y approaches 0, y is very small value approaches 0. Okay, 1 divided a very big number, you get 1 divided a very small number, you get a very big number. That's why it goes to infinity. So that's why when when x approaches 0, y approaches positive infinity. So when x is very big number, 1 divided by a very big number, you will get a very small number, but never equal to 0. So that's why you can see domain is x cannot equal to 0, range is y cannot equal to 0. So mean to understand domain and range is either you can view it from the graph, or when you have the quotient function, we always said the denominator cannot be equal to 0. When it equal to 0, you get infinity. Then the function is undefined. Because when this one, the function is undefined. Is it okay? Any question?
No.
And then x equal to y squared. Okay, this is not function. Do you understand what's the meaning of function or not? Okay, x equal to y squared. This is a graph of x equal to y squared, but this is not function. Okay, normally function you have functions. When last time we learned function is normally this one. When you put like here, you have x. This is a y. You may have like this, 1 to 1. The mapping like this, 1 to 1. This is 1 to 1. Okay, or you may have like this. if you got like this one, or you may have, let's say, 1. Okay, for the first mapping, this is what we call one-to-one relation. So this one, of course, is function. Okay, this one is what we call many-to-one. Okay, for example, you have -2 or +2, you map to 4. For example, y equal to x squared. X -2 or +2, the y you get 4. Okay, this one, for example, x is 1, x is 1, y you get -1, +1. Okay, for example, when, okay, the third K1, for example, when x is 1, we obtain y is -1, okay, and +1. So this is what we call one-to-many. Okay, for function, must be one-to-one or many-to-one. If one-to-many, this is not function. So that's why this one is actually not function. X equal y squared is not function because you have one x value mapped to 2y. When x is 1, y is 1, and y is -1. One-to-many. This is not function. Okay, many-to-one. Okay, many-to-one. For example, x -2 or +2, you map to 4. That's why the graph just now, quadratic graph, y equal to x squared is function. This one is not function. Is it clear? Okay, what is function?
Yes.
So this one, these 3 types that I draw is actually, you can call it relation, hubungan, relation. Okay, only one-to-one and many-to-one relation is called as function. One-to-many relation is not function. And then so this one is not function because you have, okay, many-to-one. 2x go to 1y. So this is not function. Okay, but from the graph, from x equal to y squared, if I only take positive part only, so I will take this graph, positive part. So mean x equal to y squared, or from here you take make y as a title. So y squared, so you have a positive, negative, square root x, right? So when you take positive, when you take positive square root, so you get y equal to positive square root. It's actually from this graph, y is positive, that's why it's only positive part here. So this is a graph y equal to third x, which is take up from the graph x equal to y squared. So this one not function, but when you cut the graph, okay, at the y-axis here, now you get this graph. It's actually, okay, from x equal to y squared. When you make y as a title, you have positive and negative square root x. Positive square root will be upper part. Okay, if you take a lower part, there's a y equal to negative third x. So now this one, this is function because now, okay, when x is 1, y is 1, only one value. So this is function. So this one is function, huh? And okay, the purpose that I put this square root function later on, because when you have square root, if x is negative value, then okay, we have a negative square root, we have a complex number. As what I said, function must be real number. That's why when you see you have a square root function there, you will always set x greater and equal to 0. That's why this is what your domain. Okay. Your domain is exactly x greater and equal to 0. And the range is actually the value of y. So this is positive square root. That's why y is greater and equal to 0 through 0. Y greater and equal to 0. So I can see from the graph, x is actually greater and equal to 0. That is the domain. Range is actually the value of y. Also y greater and equal to 0. So this one will give you a simple functions. Later on you may have complicated. So when you meet the square root function, you just set whatever inside the square root greater and equal to 0. So is it okay?
Yes.
Okay, this one is similar. This is only negative part, lower part. That's x still great. The domain. Domain set whatever inside square root, so must be positive. Then y equal to negative. Even though this one positive, but multiply with negative, that's why y is less than or equal to 0. And then how about this is a graph of y equal to x cubed. Can you now tell me what is the domain here? What's the domain for y equal to x cubed?
Negative infinity
To positive infinity.
positive infinity. Yes.
How about the range?
Negative infinity, positive infinity.
Yes, because when you see y equal to x cubed, x can take up any value. And then since x take up any value, y also any value. That's why x negative infinity to positive infinity, y also same thing. This is a circle. This is not function, but just show you because later on multiple integration you need to familiar with all kind of graph. So this is a circle, x squared plus y squared equal to 1. So this is an equation of a unit circle. Of course this is not functions. And this one also not function, but just purposely show you this is a ellipse equation. X squared over 9 plus y squared over 4 equal to 1. So these two are not function, but you need this all kind of graph during the chapter 2. That's why I just show it here. And if you want to sketch the graph of this ellipse, when you let this one is y. When you let y 0, then you have x squared equal to 9. So x will be positive negative 3. That's why this is negative 3, positive 3. Later on, when you let x equal to 0, later on, if you let this one 0, so y squared over 4 equal to 1, or y squared equal to 4, y will be positive negative 2. So this one negative 2, positive 2. So we okay 1, 2, 3, 4. Then you can roughly sketch. This is the ellipse. If circle, you see coefficient of x squared, y squared must be positive and same value. But if the coefficient of x squared, y squared different value, but positive, you are actually have ellipse. Okay, but these two are not functions. And then from the circle, okay, equations, just now we have the circle, you need circle x squared plus y squared equal to 1. Okay, if I just want the upper circle, so mean you make y as a title, so y squared equal to 1 minus x squared. Okay, and then to make it and then you want y as a title, that's why y you have positive, negative, third 1 minus x squared. Mean initially from circle, okay, if you cut it by here horizontally and take upper part, then you take y positive. That's why here y you have positive, negative. So you take positive part. That's why y equal to positive third 1 minus x squared. Initially circle is not function, but if you cut the circle into top part, bottom part. Now you want the top part. The equation will be y equal to third 1 minus x squared. Okay, so now this one become function. Okay, become function. So you have what? Okay, y equal to third 1 minus x squared. To find the domain, okay, the domain, as what I said, when you have a square root function, you set whatever under the square root, okay, greater and equal to 0, so that the square root is defined as a real number, not complex number. So that's why you have, okay, 1 minus x squared greater and equal to 0, or 1 greater and equal to x squared. So I will change it, x squared less than or equal to 1, or x squared less than or equal to 1. So this one we have here, negative 1 and positive 1. So okay, so the domain for this case is actually, you can set, okay, the domain is x squared less than or equal to 1. But since we know this is a circle graph, the x is actually from negative 1 to positive 1. And the range is actually the value of y. So it's from 0 up to 1. If you set it this way, you get like here, x squared less than 1, you cannot say x less than or equal to positive negative 1, cannot. Because this one you have a ways to do it. When you have a inequality, you have a way to do it. This one is wrong. But since we know this is on the graph of circle, x is actually defined from negative 1 to positive 1. That's why the domain is from negative 1 to 1. And the range is value of y is from 0 to 1 for this case. Okay, any questions? This one is similar, only the negative part. Move a bit faster. Okay. Now we have the ln graph. Okay, y equal to ln x, y equal to exponent x. Okay, for y equal to ln, the graph is actually when x is 1, okay, y equal to ln 1, you have 0. Okay, the ln graph, if you try to put ln 0, will give you infinity, mean undefined. Mean for y equal to ln x, if you set x cannot be equal to 0, because you see from the graph x never touch 0. When x approaches 0, y approaches negative infinity. So when x goes to a bigger number, y goes to also positive infinity there. That's why the domain for y equal to ln x is actually x cannot be equal to 0, where the x is a real number, and the range is actually from negative infinity up to positive infinity. This is a ln graph. So this is a simple ln graph. So when in function of two variables later on, when you see the logarithmic logarithmic function, you will always set whatever inside the ln cannot be equal to 0. And for the graph of y equal to exponent x, you see this one, x actually no restriction. X can take up all the value, but here plotting purpose we just plot here. Actually for y equal to exponent x, x can take up any value. So mean for y equal to x, the domain is actually x is negative infinity up to positive infinity. The range. When x from negative infinity up to positive infinity, you see y also only take up positive value but never equal to 0. That's why the range is y cannot be equal to 0, where y is a real number. If you don't believe it, just put up y equal to exponent x. Just try to put up the value. Y is negative, exponent negative, very very big number. It will never, it just approaches 0, but never never equal to 0. And for y equal to exponent x, is actually when x 0, because exponent 0 is 1. So you have here. When you want to sketch the graph of y equal to exponent x, what you need to do, when x equal to 0, exponent 0 is 1. So you have 1 point. Then the graph, what we call exponential graph. Approaches 0, y approaches 0 but never equal to 0 and goes up to positive infinity y value. And then for ln graph, ln 1 is 0. So cutting this point, and then goes down, approaches negative infinity. When x greater than equal to 1, exactly approaches y approaches positive infinity. So any question? I have revised back some linear graph, some of the circle, ellipse, and square root functions, quotient functions, logarithmic, exponential functions of one variable. So make sure you understand it, because you are going to use it to do domain and range for function of two variables. So any question before I proceed?
No.
Very good. Then now we move to the actual content. Function of several variables. For example, the minimum you must have two variables. So we get several variables. For example, you have function of two variables where x and y are what we call independent variable. Independent variable. Z is actually the dependent variable. Z depends on the value of x and y. Independent variable also what we call the input. Dependent variable is the output. The input is actually our domain. The output is what? The range. So for function of several variables, your domain will be the x, y value. If function of two variables, the domain will be an x, y value. Okay, the range will be your z value. Okay, for example, you have A equal to x, y. Area is depend on the width and the length. Okay, the work is depend on the force. Okay, work equal to force times distance. Or volume is equal to pi r squared h, volume of a cylinder. Volume depend on radius and height. So function of two variables. Okay, we have function of three variables. So now x, y, z are the input or independent variable or domain. W is the range or the output, okay, or the image. For example, you have volume, okay, of a cube or cuboid is the length times the width times the height. Okay, and now, okay, dimension. And just skip it. Skip this one. So just now I mentioned, okay, function of two variable x, y, independent variable, or what we call this one is a domain. Z dependent variable or the range. So three variables, so same thing. Okay, x, y, z become the domain. W is the range. So if we have, okay, up to n variables, okay, if n variables, let's say up to x1, x2, x3, x4, xn. So all the x is actually the domain. So this one we can put another variable, let's say w. So w is a range, the domain x1, x2, x3, x4 up to xn. So now we're going to look at domain and range of function of one variable, two variables. Okay, for example, okay, let's fxy equal to square root 1 minus x plus 5. So as I said, domain and range, okay, domain and range, just now we revised for function of one variables. Okay, we did see just now we have what? Y equal to set x, right? I said set whatever under the square root here, means x must be greater than equal to 0 so that the function is defined. Because if we not set x greater than 0, x, if we take negative value, then you have here. So this is a complex. Function must be real number, so cannot. That's why you must set x greater than equal to 0. So hence keep for this, to make the function define and a real value, you set 1 minus x plus y must be greater and equal to 0. You can take up 0, no problem. Let's say y equal to set 0 equal to 0. So you just set 1 minus x plus y greater than equal to 0. And then you may have y minus x greater than equal to 1. Then this will be the domain. Okay, range, okay, will be a little bit okay. So this one is a domain. So this will be set as a domain. So the domain you can put is y minus x greater than equal to 1. Or you want to simplify again, or you want to simplify, let's say y greater than equal to 1 plus x. Then you can put the domain exactly y greater than equal to 1 plus x, where, okay, I can put the x is real number, y must be real number. So this is a domain. Okay, range. Okay, let's say let fxy, let's say equal to z. So I have z equal to cert 1 minus x plus y. So range will be your z value. So how to determine the range? Okay, remember just now y equal to cert x, the graph is exactly like this. Y is exactly, for y equal to cert x, the range is exactly y greater than equal to 0, because we have what? Positive square root. Here also positive square root. That's why the range is actually z greater than equal to 0, where z is the real number. Okay, so is it okay? This is domain and range for function of two variables. Domain and range, we have found it. And then evaluate f21, f negative 4, 3, and f2t, t squared. Okay, so to evaluate it, you plug in x is 2, y is 1. And then you get the value. X is negative 4, y is 3. Here. I want to show you using the okay, to evaluate f21, f negative 4, 3, this one. Okay, of course, you may plug in x is 2, y is 1, okay, x is negative 4, y is 3, and you evaluate it normally. Okay, when f2t, t squared, plug in x is 2t, so 1 minus 2t, y is t squared. Okay, and this one can be factor as 1 minus t minus 1 squared, so t squared minus 2t plus 1. Okay, and I will show you actually your calculator. This is a new model. Later I can send you the link. You can have a free download of this emulator of this new version of calculator till this end of August 2001. 2021 this year. And then for example, I want to plug in this function 1 minus, you see the red color is a variable that you can use in your calculator. To use the red color, press the alpha plus y, calculate. So they ask you the x value, so x is 2 equal y value 1, so you get 0. Calculate again for second. X is negative 4, y is 3, so you get 2 sub 2. But of course the third one, 2t, t squared, you cannot. You can only calculate numeric value, not the not symbolic, only numeric. So these two you can make use of the calculator. And then domain range, we have solved it just now. Domain range, any problem? Domain just now, y greater and equal to x minus 1. Range is z greater than equal to 0. Second one, find the domain of each of the following function. Okay, so you can let's this one, z equal x squared third y. Z equal to x squared third y. So domain will be a xy value. So for when you have the product function like this, first of all you may look at you just look at just close your third y, then you look at z equal x squared. Z equal x squared, you compare with the function of one variable y equal x squared. Remember the graph of y equal x squared? The graph is like this. Because if you can memorize the graph, it's easy for you to get the domain and range. Y equal to x squared, quadratic or parabola graph, where x is here. This is the y. So mean x take up all the value. Mean x can be any value. So mean in this case, x exactly belong to real number. X is real number. And then how about the y here? So this is third y. So you set y here greater than equal to 0, so that the square root function will be defined. That's why your domain is actually x take up all the real number, but y greater than equal to 0, and y also real number. So is it okay?
Okay, doctor.
If the b another one, let's say z equal ln x squared minus y. Remember we already said that in order for ln function to be defined, remember y equal ln x, where you must set x greater than 0, because the graph of ln like this one is 1 here. X must be positive. Y equal to ln x is only defined when x is positive value. X is positive value, but not equal to 0. So x is greater than 0. That's why in this part you have to set x squared minus y greater 0, or x squared greater y. Negative 1 move to the other side, positive y. So if you want y as a title, you have x squared greater than y, or y less than x squared. So this will be the domain. Domain is a y less than or equal to x squared, where the x real number, y real number. This is a symbol of set. X is a member of real number, y is a member of real number. So that's why you have to revise back, look back, the graph of exponential, ln, quadratic, cubic, linear, to understand what is the domain and range. It will help you to determine domain and range of function of two variables. So is it okay, this one?
Oh, okay.
Okay, doctor.
This one the answers straight away there. Never mind. The third one, z equals third y minus x squared. So when you see a square root, set whatever inside square root. So this one you set y minus x squared, square root greater and equal to 0. That's why y greater and equal to x squared here. For quotient function, so you have to set xy cannot equal to 0. Because if we have 0, 1 over 0, infinity, so the function is not defined. So xy cannot equal to 0. Okay, for sin xy, okay, look back the graph of y equal sin x. Okay, we actually plot negative 2 pi to positive 2 pi. But actually the graph is periodic. You can plot from negative infinity up to positive infinity because the graph is actually repeat. Okay, for negative side also same thing. So that's why for y equal to sin x is actually x, take up real number. In the domain is x belong to real number. The range, the graph of sin x actually y, okay, maximum is 1, minimum is negative 1. That's why the range here. Okay, square root, okay, mean included, square root is included, mean what, okay, but this one is z, so for z similar, mean x and y take up all the real number. That's why it's entire plane. Okay, entire plane is actually 2D. Plane is 2D, 2 dimension. So mean you have this is x, this is y, 2D. So with xy, then you get the z. So the graph of z is 3D. But if you x and y here, so entire plane means all xy take up all the value. Okay, but z follow the graph of y equal to sin x exactly from negative 1 to positive 1. Okay, and the round bracket mean not included. Okay, sometimes we put we put in the set. This one we put in another form, from negative infinity to 0. Okay, or I can just put straight away put this one z not equal to 0. Okay, this one positive z equal to positive square root. That's why the range is z greater than equal to 0. And then bottom 3 you have is a function of 3 variable. W equal to x squared plus y squared plus z squared. Okay, even though I said you have to set whatever inside the square root greater and equal to 0, but x squared you get positive value, y squared also positive value, okay, z squared also positive value. That's why in this case, even though x, y, z is negative, but because of the square root, because of the square root, x squared, y squared, z squared always positive. That's why x, y, z can take up negative value, 0, positive value. That's why it's entire space. Mean all because it's x, y, z. That's why it's space. Take up all the value 3D in x, y, z. There's no restriction of any value that cannot be taken by this function. Mean x, y, z take up all the value from negative side, positive 0 or positive value. So that's why the domain is entire space. Okay, and the range is actually because positive square root. That's why it's actually W is greater than equal to 0. So you see square root, the square bracket mean included 0, included 0 up to included infinity. So this is round, sorry, typo. Not included infinity, round. Round mean not included, or you can put W greater than equal to 0. Okay, for the second last function, W equal to 1 over x squared plus y squared plus z squared. Okay, for quotient function, we said you must set the denominator here cannot be equal to 0. So mean you will set x squared plus y squared plus z squared cannot be equal to 0, because if you have 1 over 0 become infinity, the function is not defined. Okay, and for x squared plus y squared plus z squared not equal to 0, okay, happen if and only if x, y, z are 0. Okay, only one case happen. If x is 0, y is 0, z is 0, then we'll get x squared plus y squared plus z squared equal to 0. That's why the domain, you can take up all the value except x, y, z cannot be equal to 0. And then, okay, for this case, this one, w cannot be equal to 0. Okay, remember we have, okay, show you the function, the graph of y equal to 1 over x. It's like this. Okay, when you have 2D, x, y, x and y. Okay, when you have function one variable, 1 over x, y never touch up 0. So that's why w equal to 1 over x squared plus y squared plus z squared. Similarly, w never equal to 0. And follow the pattern of y equal to 1 over x. But in this case, y is range. In this case, w is range. Okay, you may stop me if you have any questions. Huh? So for, okay, so for w equal to 1 over x squared plus y squared plus z squared. Okay, and any problem? Okay, if no, we have the last one. W equal to xy ln z. Xy ln z. Okay, you can break it. When you look at w equal to x, w equal to x is similar, you have the y equal to x, right? Linear. So x take up all value. So that's why x is real number. Okay, y also real number. Because you break it, w equal to y. When you break w equal to y, it's similar with y equal to x. Okay, y equal to x, horizontal is x, vertical is y. If you put w equal to y, when you plot the graph, y become horizontal, w become vertical. So similar graph, only changing of variable. So if y equal to x, the range is x is a real number, w equal to y, y also real number. And then now you focus on w equal to ln z. So for the ln function, you set z greater than 0. Because if z equal to 0, ln 0 is undefined. That's why for this case, we have xy is a real number, but z is a positive value. That's why it's a half of the space. Okay, this is a 3D graph. 3D, because of x, y, z. But x, y take up positive, negative, all the number, including 0. But z must be positively. So it's upper part of the 3D graph. Half space where z greater than equal to 0. And the range is negative infinity up to positive infinity, because x, y, any value, sometimes range will be a little bit difficult to see compared to domain. Okay, because of graph of ln, remember y equal to ln x, the range is actually here. If this is x, this is y. Okay, range is y take up from negative infinity up to positive infinity. And then y equal to x, range also positive infinity up to negative infinity up to positive infinity. If w equal to y also same, ln z also same. That's why the combination, the range is also from negative infinity up to positive infinity. Means the range, okay, you look, okay, when you have the function of several variables, you can break it become like here. When you break it, w equal to x, w equal to x. Okay, the domain is actually the x take up real number. Okay, the range is actually your w take up real number. So for w equal to y, domain is a y real number. Okay, range also, okay, w real number. Okay, and for w equal to ln z, okay, your domain is z must be greater than 0, where the z is a real number. Okay, range, follow the graph of y equal ln x. Ln take up the range, take up real number. Okay, so it's w is a real number. Okay, that's why you combine this one. Okay, w equal to x, w equal to y, w equal to ln z, all the range are real number. That's why the range here is from negative infinity up to positive infinity. Okay, and for the tutorial for domain and range, you can download it from the author. You can try to answer. Okay, so any questions? Okay, any questions?